Hi, welcome to the next part of part 6, solving equations. We're just going to dive right into it. So for number 45, first thing we need to do is the distributive property. I better write smaller for these ones. So 3x minus 21 plus 5 equals negative 2x minus 8. All right, 3x minus 16 equals negative 2x minus 8. Now I need to combine like terms across my equal sign. So if it helps to draw that line down the equal sign, go ahead and do that. I'm going to add 2x to both sides. Sorry. Hey, shh. 5x minus 16 equals negative 8. Then I add 16 to both sides. I get 5x equals 8. Divide by 5, divide by 5. X equals 8 over 5 is a perfectly acceptable answer to that. Number 46, I'm going to start by getting rid of that 3 in the denominator by multiplying both sides by 3. So then I have x plus 1 equals 15. Subtract 1 from both sides, x is 14. For number 47, you might be tempted to expand the problem so that you make a trinomial, but that's not actually the way that you solve this. When you have two binomials like this, or you have like a trinomial, you need to break this into two pieces to solve for it. So if our answer is equal to 0, then either x plus 4 has to equal 0 or 9x minus 3 has to equal 0. We can talk about in class why that is if you're interested or don't know. But we're going to solve these two separate equations. If I subtract 4 from both sides, I get x equals negative 4 as one of my solutions, and then 9x, add 3 to both sides, 9x equals 3. This one, I think we might have some problems with people rushing because when you divide by 9, remember that the 3 is on top. This is 3/9, the fraction. So this actually is going to convert to 1/3. This does not turn into 3. It's not 9 divided by 3, it's 3 divided by 9. Okay, moving on to 48. To solve this one, we're going to want to do the same, we're going to do the similar type of thing to what we did in 47. So we need to start by factoring it. So I've got negative 12, and then there's a 1 in the middle. So I need numbers that are right next to each other. So how about 3 and 4? So x, 3 and 4, this is going to equal 0. And I have a positive 1x in the middle, so I know that the 4 has to be positive and the 3 has to be negative. Now I'm going to break this apart and do x plus 4 equals 0 or x minus 3 equals 0. If I subtract 4 from both sides, I get x equals negative 4 as one of my answers, and then add 3 to both sides and I get x equals 3 as the other answer. Okay, same deal with 49. With 49, 35, I automatically think of 5 and 7. And I'm in luck because I look at my middle term and it's a 2, and the difference between 5 and 7 is 2. And I've also got a negative 35, so I know one of those has to be negative subtraction. So x, 5, 7, and then I have a positive 2x, so I know that the bigger number, the 7, has to be the plus, and the 5 has to be the minus. This equals 0. X minus 5 equals 0. X plus 7 equals 0. Add 5 to both sides, and I get x equals 5. And then subtract 7 from both sides, and I get x equals negative 7. Okay, for number 50, this one is a little tricky. We are going to use completing the square to solve this. And with completing the square, you're going to take b, so this is our b, and you're going to take b and divide it by 2 and then square it to figure out what your c should be. That's what c is supposed to be. So this one isn't the nicest completing the square problem I've ever seen, but to complete the square, basically, you're going to add something to both sides. You're going to add whatever b divided by 2 squared is. And for this problem, lucky us, it's 9 over 4, because you have 3 over 2, and then you square that, you get 9 over 4. Oops. It's important that we add 9 over 4 to both sides here. Otherwise, we've messed up our equation. It's not equal anymore. Once we've got this, you're going to take this and factor it, and you can actually just make this into x plus 3 over 2 and then the whole thing squared. And this other side turns into, this could be negative 4 over 4 plus 9 over 4. So that turns into x plus 3 over 2 squared equals 5 over 4. Now we're going to take the square root of both sides to get rid of that square. And we get x plus 3 over 2 equals the square root of 5 over the square root of 4. So that's going to give us 2. Like I said, this one's a little painful. Then you're going to subtract 3 over 2 from both sides. I'm running out of space. But when you subtract 3 over 2, you get x equals square root of 5 over 2 minus 3 over 2. The denominators are the same, so you can write it as square root of 5 minus 3. Make sure it's not under one square root. The minus 3 should be separate, and then all over 2. And that is your answer. So, like I said, not the nicest one, but what you gonna do? For 51, you have absolute value, and what you're going to do with absolute value stuff is you're going to take the equation and you have two scenarios. So this could either equal 5 or it could equal negative 5. And that's because you could put a positive or negative number inside of an absolute value sign and get the same answer. So we have two separate possibilities here, and we just need to solve them. So subtract 1 from both sides. Negative 4x equals 4. Divide by negative 4, divide by negative 4. X equals negative 1 is one of my solutions. And then this one's not going to be quite as nice. Over here, I've got negative 4x equals negative 6. Negative 4, x equals, the negatives are going to cancel here, and I get 3 over 2 as my other answer. For 52, this is a great practice problem. You need to solve this just like a normal equation, but there's just one catch. Whenever you're multiplying or dividing by a negative and you have an inequality, you're going to have to flip the sign. So we've got a negative 4x here, so we know we're going to have to flip the sign eventually. But let's just start out like normal. Negative 4x is less than or equal to negative 2. Then when we divide by negative 4 on both sides, that's when we switch the sign, and we would end up with positive 1/2 there. And that's your answer. And then this last one, number 53, you are going to want to get everything away from the square root of x, just like you would get everything away from a normal x, and then we can deal with the square root. So I start by adding 3 to both sides. 2 square root of x equals 8. Divide by 2, divide by 2. Square root of x equals 4. Now I get rid of that square root by squaring both sides. This turns into x, and then this turns into 16, and there's your answer. Thanks for watching.